Okay. So again, sequences is kind of like a generic word, or a word that we use to just describe like a list of numbers that maybe are created by like a regular pattern, or maybe sometimes there's a formula attached to it and stuff like that. Okay, and there are different ways of coming up with sequences, right? Different kind of like formulas you can use. All right, and some of those ways are so special they have names. So for example, like we talked about the Fibonacci sequence, right? A list of numbers, and you get those by adding the two previous numbers to get the next number kind of thing. For an arithmetic sequence, okay, that's a named type of sequence. And from your prior experience, an arithmetic sequence is called arithmetic because, well, it's a sequence of numbers okay, and so what, well, maybe you describe it in your own words here. I'm about to do it maybe in a weird way, but what makes an arithmetic sequence an arithmetic sequence? You guys remember? What's the pattern that we do here for an arithmetic sequence? To classify something as arithmetic, what are you doing every time? Ooh, we don't remember. Or we think we remember, but maybe we're not sure enough to say. Okay, so it's a sequence of numbers whose difference, okay, between consecutive terms, okay, is constant. Okay, now that's a very like mathematical definition. You might remember arithmetic sequences as add the same number each time. Okay, that's also a way to kind of like think about arithmetic sequences. All right, so a sequence again is just a list of numbers whose difference between consecutive terms. So an individual number in a sequence is called a term. All right, and the terms are of course numbered as well. So like you can talk about, well, let's say for example here, let's just get an example of this. All right, so for example we've got like 3, 7, 11, 15, ... Okay, 3 is called the first term. Okay, normally designated as a sub 2, and then we have a sub 2, a sub 1 because it's the first term. I was getting ahead of myself there. 7 then would be the second term, so a sub 2. 11 is the third term. 15 is the fourth term. And if we wanted to go all the way up to the end there, we could say something like a sub n for the nth term. Okay, a sub n for the nth term here. Okay. So now this sequence that I gave you, right? This sequence that I gave you, I haven't identified it yet as arithmetic, but is it arithmetic? Well, again, to match the definition here, we need the difference between consecutive terms to be constant. So what's the difference between these two consecutive terms? 4, right? What's the difference between these two consecutive terms? 4 as well, right? And from 11 to 15? 4 as well, right? Okay, positive 4 is there, right? And so looking at this pattern, from what we can see, is it going to be arithmetic? Yes, okay. Since it's arithmetic, then, it must have a common difference, okay, right? And what is that common difference here? 4, right? 4. Consecutive terms. So you could do, 7 minus 3, or you could do 11 minus 7, or you could do 15 minus 11, and all those are going to equal 4. Whoops, the common difference there. Okay, so it is arithmetic. All right. So then, knowing that, what is a sub 5 going to be then? The fifth term will be what? I heard 19, I heard 23. What's the fifth term going to be? 19. 19, 19, 19, 19. What's the sixth term going to be? 23, right? Just keep adding 4, right? We had the fourth term. The fourth term was 15, right? There was the first term, second term, third term, fourth term. Fifth term will be 19, sixth term will be 23. What about the 100th term. That. What'd you say, Parker? 399? What were you saying, Julia?
I'm completely off. I said 403.
403? Maybe you're off. Maybe I'm not saying Parker's right. You might be right. Other ideas? What's the 100th term here? Right. So, Julia, what was the strategy you tried to employ here? Or how did you try and where'd you get your guess from?
I tried to do the A, which is the 100, which is 100 times 4 equals 400.
400. Okay.
Plus the 3, but it would be actually the opposite, that you would minus the 3 because A1 is the 3.
So what should the answer be then?
It should be 1.
Yeah. Okay, exactly right. It's going to be 399 here. 399 is what we want. Okay, so the idea is, we kind of, we have this, we're starting at A sub 1. All right, we got to go 99 more times out, right? So we're starting at A sub 1. We have to go 99 more terms to get to the 100th term. So that's 99, and every time we go up a term, we're adding 4. So it's 99 times 4, right? 99 times 4, and then we're going to add that first term to it right there. So first term, 3, and we add 4 99 times. So 3 plus 4 times 99. 4 times 99. Okay? That's the idea. All right, so yes, it would be 399. Okay? Question.
I don't know if this works for everything, but you could have just done the number times 4 minus 1.
Yes, so we'll get to that here. So there is a formula we can use here to find the nth term of an arithmetic sequence. Okay, an nth term. So that means any term you want. We could use this to find the 500th term, the 1000th term, the millionth term, all that kind of stuff. So we'll say the formula is going to be this. We'll say the nth term, okay, is equal to, and we'll start with our first term there. Okay, and then we'll add to it the number of the term we want minus 1. Why? Because we're starting at A sub 1, and so we don't want to just do n. We're going to do n minus 1, right? Because we're going from 1 to n, so the difference between those two is n minus 1. Okay? And then times the common difference, d. Okay. Just like that. So, again, what do these mean? That's the nth term. That's the first term. This is the number of the term. And this is the common difference. Okay? This is one formula you can, if you want to memorize it, you can. But I would also argue it's not super necessary because if you were to plot points here where you had 1, 3, 2, 7, 3, 11, 4, 15. So if you graphed these, the number of the term as the x coordinate, and then the term itself as the y coordinate, so the 1, 2, 3, 4 for your x's, 3, 7, 11, 15 for your y's, what kind of graph would you get? Linear. It'd be a line, exactly right. And we know how to write the equation of a line, right? We can write the equation of a line given 2 points. And so really, it's not necessary for us to use this formula. You could also just write the equation of a line, where x is the number of the term and y is the term. The term itself, okay, the term's value, and then just go from there. You don't really need to memorize that formula or anything like that. You can just use the equation of a line because it's linear. It's a relationship there. Okay. But anyway, let's just check to make sure that Parker and Julia, in their thinking were correct here. So let's use the formula for that. So if we want to find the 100th term from our series up there, well, the first term. What was the first term for our sequence? Our sequence. 3. And we'll add to that number of the term, so 100 minus 1. And what's the common difference? 4. Okay, so 100 minus 1 is 99, times 4 is going to give us, I'm going to guess 396, and then plus 3 does in fact give us that 399 that we thought it should be. Or that, sorry, not we, but Parker and Julia thought it should be. Okay, okay. So good job. All right, let me give you guys one here. So why don't you guys try and this one maybe is just an extension here, write an equation for the nth term of the sequence. I don't know why I put that as a question mark, but anyway. So the same sequence we were talking about, the one that was started with 3, 7, 11, 15, okay, write an equation for the nth term of that sequence. So what I mean is, if I wanted to come up with just a generic formula for any term, an nth term, what would that formula look like? Okay, so go ahead and write that equation. Simplify it too, I would say. Shouldn't take you too long there. Okay, and I'll do the same thing. So let's just write a generic equation that will find the nth term of the sequence. Okay, we found the 100th term. Come up with that equation just for the generic nth term. Okay. So if we want to find the nth term, it'll be a sub n equals, again, our first term does not change, it's still 3, but instead of 100, what should we put in place of the 100 now? For a generic term, n. We'll just put an n, yeah, n minus 1, okay? And then what's our d, what's our common difference here? 4, okay? So you could leave it like that if you wanted to and say there's a formula for the nth term. We could simplify it, though, and say, okay, well, it's really 3, distribute the 4, plus 4n minus 4. And so you could also say then 4n minus 1 if you wanted to there. Okay, so this is fine, but this is simplified, of course. Okay, both will give you those formulas. So, yeah.
Could you find a linear version of an equation for this?
Yeah, absolutely. Yeah, absolutely. So you could, pick 2 points, something like that, write the equation. You'll end up with this. I mean, you can see it's like essentially slope-intercept form, right? 4n minus 1. So there's your slope, there's your y-intercept. Okay, but of course, this y-intercept is like what you would call like the 0th term, right? So if you went like back from 1 there, if you went back 4, it'd be at -1, and there's your y-intercept negative 1 there. Okay. All right. So let's keep on this track a little bit here. I got a few more questions with the arithmetic sequence stuff that I want to look at. Okay. So our directions here will be to write an equation for the nth term of the arithmetic sequence okay, and find the 20th term. Okay, oops, I got it. Here we go. Write an equation for the nth term of the arithmetic sequence and find the 20th term. So we'll do one here together, and then I'll have you guys try one on your own. So, and here we're given some information. Okay, so here we're given some information. Okay, what does that a sub 1 mean? It's the what? First term, and d stands for common difference. Okay, so our common difference is still 4. I'm not really changing it up too much there. But if I wanted to write this sequence out, I would start with 5, and then my next term would be what? 9, and then 13, and then 17, and you get the idea. Okay, plus, or comma, Okay, let's write then the equation for the nth term. So the nth term will be equal to what? Okay, 5 plus n minus 1 times 4, the common difference. There it is. Okay. And if we distribute and simplify there, you're going to get 5 plus 4n minus 4, or 4n plus 1. So there's our formula. And now we'll find the 20th term. Okay. You could, if you wanted to, do this sequence out until you find the 20th term. But really, let's just use the formula, right? So we'll plug 20 in for n. 4 times 20 plus 1, 81. Okay, 81. All right, questions on any of that? Pretty simple, yeah? All right. What about for this one? Same directions. Same directions. We're going to write an equation for the nth term and then find the 20th term. What are we given in this case? What information are we given here? Rumike.
Not the common difference.
Okay, yeah, we're not given the common difference here. But what does this information say? A sub 1 means that's the
First one.
first term. So the first term is negative 4. A sub 5 means it's what? The fifth term. So we have the first term and we have the fifth term. And we're supposed to come up with the nth term, an equation for the nth term. Well, let's see what we've got, right? We've got a sub n is what we're going to try and find. We have a sub 1, it's negative 4, plus n minus 1. But what don't we know? Common difference. We're told it's arithmetic, so we know that there is a common difference. We don't know what it is. But how can we figure it out? How can we figure it out here? Any ideas? Yeah, Ramike?
Put like 16 in for the nth term and solve for d.
Ah, okay. So you want to use this information, plug it into the equation here, and solve for d. Okay, we can do it that way. That would work. Okay, so we'll put our unknown quantity for the common difference there, d. We'll put that in. And we'll put 16 in for a sub n. And that's negative 4 plus, and then 5 minus 1 times common difference d. Okay, so we'll add the 4 over, make it 20. 5 minus 1 is 4d, and so d is what? Five. Okay, and so our nth term then, negative 4, whoops, darn it. Negative 4 plus n minus 1 times 5. Okay? And so then finding the 20th term, super easy. A sub 20 is going to be negative 4 times 20 minus 1. Oh, just do that on that part. 20 minus 1. Darn it. I forgot the plus again. Times 5. So what? 95. So 91. Okay. 91. Did anyone get the common difference in a different way? Want to share it? Everyone do that way? Yeah, Julia?
You find the difference between the two and then divide by 4 because that's the difference between those two numbers.
So the difference between like 16 and negative 4, you mean?
Yes.
So yeah, so another way to think about it, right, is that we have to go from negative 4 to 16 in, well, 4 steps, right? From a sub 1 to a sub 5, that's 4 terms between it, right? So it takes 4 kind of jumps there. And so yeah, the distance here is 20, right? From negative 4 to 16 is 20. 16 minus negative 4 is 20. And then divide by 4, you get the 5 again, just like that. Okay. Megan, were you going to say something similar to that?
Yeah.
Okay. I think that's the only other way I can really think about it. Anyone come up with something different than that when you got this? Okay. Cool. Cool. Any questions on that then? Okay, well, now I want to make sure. Excuse me. Let me check my calendar here real quick. I just want to make sure I'm not jumping to the wrong thing next here. All right. Okay, arithmetic sequence series, geometric sequence. Okay, so we're just keeping it. Gotcha. Okay. So then, one other thing I want to introduce here too, they're normally taught together, or maybe they're not normally taught together because I don't know if you guys have heard of it before. Have you guys ever heard of a series before? Okay, I don't know if you have either here. So a series, okay, that is the sum of a sequence. Okay. A series is the sum of a sequence or a list of numbers. Okay? So a sequence, okay, you have something like this. A sub 1, comma, A sub 2, comma, A sub 3, comma, dot, 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 comma, A sub n, comma, dot, dot, dot. Right? Keeps going. Whereas a series takes that sequence and adds them. Okay? And in mathematics, these are so common, I guess, or something, that there is a different way to write out the sum rather than just writing out like as a list like this. Okay, we don't really have a different notation for this as far as I understand. Maybe there might be. But we have a notation for series here that we need to be familiar with. Okay, and it's called sigma notation. Okay? So, has anyone in here taken Greek? No? Okay, so sigma is like the Greek letter that they use to make the S sound. And we use sigma because for sum. Right. You see it on the frat, or I don't know, do sororities use sigma too?
I think so.
They do? Because some letters I feel like only fraternities use, and some letters only sororities use. But maybe that's a wrong. Anywho, we use this Greek letter sigma, okay, and then we use a number down here, like a letter down here, like I, okay? It's only I. And then N up there, and then A sub I. Okay. So what does this mean? What does this mean? Okay, so it's the sum from I equals 1 to n of A sub I. So that's what this is representing right here. You can see that where are we supposed to start? We start at I equals 1. So we start with A sub 1. And then we're going to count up to n. Okay, and maybe I shouldn't have the plus dot 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 there now that I'm thinking about it. Yeah, I'll get rid of that. We're going to count up to n, and that's how much we're going to add up to. So A sub I, and then we'll do A sub 2, A sub 3, or sorry, A sub 1, A sub 2, A sub 3, A sub 4, all up to A sub n. And this represents that entire sum right there. Okay, that represents the entire sum right there. Okay, so let me just give you a quick example of what I mean by this. So for example here, let's say we had this. Okay. I know I'm using I, and that looks like the imaginary number. It's not an imaginary number. It's just like a variable that we're using. Okay. What's the first term in this series going to be? Well, our terms are defined by I, right? What's I start out as? 1. And we're going to add to that, what's the next value of I? 2, right? We're just going to count up. We're just counting from 1 up to 100. So 2 plus, and the next one will be 3 plus 4 plus dot 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 plus, you get the idea. We're going to add a bunch of numbers in there. And then 96, 97, 98, 99, and all up to 100, we're going to stop. Okay? Now, we have a sum here, right? We're going to add all these numbers up. All right? There's actually like a story or a legend, maybe I'll say, about a mathematician named Gauss, Gauss. Okay. And it was back when he was in like elementary school, apparently. I think is like how the story goes. And it's something like the class was particularly unruly, and so the teacher was looking for a brief break from having to try and control this crazy class. And so the teacher came up with the idea of giving her or his, I don't know, elementary school students a problem for them to do. And they posed to the elementary school students, come up with the sum of the first 100 counting numbers, right? And so ideally this is going to take some time because they had to like sit there and do 1 plus 2 plus 3 plus 4 and start carrying ones and things like that and coming up with the sums. But Gauss took maybe a couple seconds and was able to bring his answer up almost like, immediately to the teacher, much to the teacher's surprise. And when the teacher, looked at the student's paper, they're like, oh, that's a different way of thinking about it. So what as legend has it, what Gauss did is, we kind of see this right here. We're going to add up all these numbers. Well, what he did then is he took the list of numbers and he flipped them around like this. Okay, like so. Oops, I forgot the pluses in there. Now, when you flip them around, notice if we add here, what are we going to get here? What's this sum? 101. And what's this sum? 101. And we're going to have a bunch of 101s, aren't we? In fact, how many 101s will we have? We will have how many of them? Not 50.
49.
Nope. 100 of them. 100, right? Well, we're going to have 100. So the sum from 1 to 100 is going to be 100 times 101. But since we did the list twice, right? We had this list and then we added the list again, but just in the reverse order. What do we need to further do to get the final sum? Divide by 2 or multiply by 1/2.
So couldn't it be times 50?
So couldn't it be times 50? Yes. Sorry, ultimately, yes. Sorry, but I wanted to make sure yes, you could. And so then you get the sum, 5,050, without having to actually add every single number up kind of thing. You just get the pattern there and go for it. Okay? And so the sum of a finite arithmetic series is the number of terms divided by 2 times the first term plus the last term. Okay. Right? What did Gauss do? He added the first term and the last term, multiplied by the number of terms, and we had to divide by 2. Okay. And so there's that formula. Bless you. N equals number of the term. A sub 1 equals the first term. A sub n equals the nth term. Okay? So we turn something that's going to be like a lot of addition into just some multiplication. Now, what is the sum of an infinite arithmetic series going to be? Infinity, right? Infinity, right? If you add up an infinite number of numbers, okay, it's either going to be positive infinity or it's going to be negative infinity that you go to, right? Even if that number is like 1/100th, okay? If you keep adding, if you keep adding 1/100th over and over again, eventually you're going to go to you're going to go towards infinity, okay? In this case, for an arithmetic series, and the sum of the infinite arithmetic series will always be infinity. So we can only do finite arithmetic series here. We can only do a finite number of terms in our series to add that up. Okay? So let's try another one here. Let's do one more together, and then I'll get you guys started on your assignment. So find So again, what does this mean? Find, the sigma stands for sum, right? Find the sum from n equals 1 to 150 of this pattern right here, of this series, 2n minus 6. Okay? Now, if you look at that and you're like, ooh, I have no idea what this thing is doing. Well, let's maybe try and write out the first few terms, okay? Truthfully, you have all the information you really need. You have all the information you need right there, okay? You have all the information you can go ahead straight to the formula if you want to. But if you're not comfortable with that yet, you want to try and write a few terms down, feel free. So let's say we're not comfortable with it just yet. Maybe we want to write down, a couple of terms. So what's the first term going to be? Negative 4, right? Just plug 1 in here. 2 times 1 is 2, minus 6 will be negative 4. Okay, and then to that we're going to add, what's the second term going to be? Negative 2, right? Again, we can just try it by plugging in n. So this is, again, n equals 1, n equals 2 here. Just plug in 2. 2 times 2 is 4, minus 6 is negative 2. Alternatively, we can just look at this and see what's the common difference of, according to this formula here, what's the common difference going to be? 2. The slope is 2. Common difference is 2. So you could also just add a 2 to get the next term here, right? Let's check it out with 3. 2 times 3 is 6. 6 minus 6 is 0. Plus 2. Plus 2. It's working. All the way up to plus dot, 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 plus the 150th term. What's the 150th term going to be? What's that 150th term going to be? $294. Again, plug 150 in. 2 times 150 is 300. 300 minus 6, 294. So the 250th or 150th term will be 294.
You minus the 6 and then minus the 2.
Minus 6 and minus the 2.
Oh, wait, no.
You're good? Okay. Yeah. This here will describe any of the nth terms there. Okay? And so now to find the sum, well, we'll just use our sum of a finite series. So we have how many total terms here? It's going to be 150 terms, okay, divided by 2, times the sum of the first term and the last term there. Okay, like so. Which is going to be 21,750 when you multiply it all out. Okay? Again, this sigma notation is only for a sum, so therefore you only should see it with a series. Series, okay? A sequence, just a list of numbers, that's going to be different. Questions on any of that? All right, so let me get you guys started then on your assignment here. It'll be out of the book. Okay, 2 different sections. So page 648, 85 to 89, and 103. Those are odds. And then page 657. Numbers 5 to 19, 59 to 69, 91, and again, those are all odds. And you may use a calculator there. Calculator active. Okay? Oh, I forgot to put the homework. Thank you. Yes, if you would please put your homework together from last week. I'll come around and get that. Yes.
That was good, thank you.
All right. All right, so if you would again put your homework together, I'll come around and get that in just a second. Let me
Are you skipping most of the day on Friday? I mean,
Cooper. We're not live.
I know, but like, are you just planning on? Yeah. You actually want to get off?